Hello, Mr. Claudia here, and today we have our last lesson of the statistics chapter. Today we're going to be looking at how to measure correlation. Remember, up till now we've talked about correlation and we've discussed it, we've used some words to describe it, but now we're going to use some numerical values to analyze it. If you remember, if I draw a line of best fit, how well does my line of best fit this data? Well, the data is not exactly all on the line, so I would say that this is a moderate regression. Moderate positive linear regression. Now this one, what could you tell me? That regression line I drew is not the best, right? Like, this is clearly some sort of quadratic. So I would say here that linear regression is not the best model. And here we have, in this one, the points are very close to the line of best fit, so this is a strong positive correlation. When something is a strong correlation, we say that the regression line is a good fit. You can see that, unfortunately, this point here, this outlier, slightly skews the data, or it skews the trend line, or the regression line. But if I can't explain away the outlier, like if I can't get rid of it, then it is part of my data set and it does affect the trend line. Okay, so when we are talking about numerically or quantitatively about correlation, we're going to use a number called R, the Pearson product moment correlation coefficient. You could just say correlation coefficient, R. And R, just like our last lesson, is some complicated formulas to calculate it. Again, just like our last lesson, we're never going to do this practically. There's no point even going through it. This is just how the computer does it, how the calculator does it. So I'm going to show you in a few minutes how the calculator calculates R. But basically, R is going to be a value between 1 and -1. R equals 1, well, that's a perfect correlation, a perfect positive correlation. If the data points, if R spits out 0, if the calculator spits out 0.7, that is a moderate. If the correlation is weaker, so you can see here that there's very spread out, this would be, the calculator would spit out a much lower R value, weak. And then down here we have no correlation at all. There's no link. Now, this is useful if you're studying, like if you're looking at a study, say like the effectiveness of a vaccine in stopping coronavirus. You want to see that the vaccine has a strong correlation to protection from the coronavirus. If you do your whole study and it's weak, so there is a correlation, but it's weak, well, you might not want to trust that study as much as one that has a stronger correlation. Similarly here, remember R can go down from -1 to 1, so if R is -1, that's a perfect negative correlation. And then we see the same sort of range. So this is a moderate, this is weak, and this is no correlation here. R equals 0. So we have this value. Remember, the value comes from that formula I showed you up there. That's what your calculator is doing when it spits out the values. By IB definition, this is how, so the IB defines the correlation as follows. So if the R value is between 0 and 0.25, it's very weak. Between 0.25 and 0.5, it's weak. Between 0.5 and 0.75, moderate. 0.75 and 1 is strong. And then technically, if R is equal to 1 or -1, it's perfect. So that's important to know, because you might get a question where we're given an R value and you have to interpret it. So let's go back to the question yesterday, which was the correlation, which was about distance to school and time to travel to school. Let's find the regression line, and then let's find the correlation coefficient. So we've already done this. Let's go down to part A. Let's write this down here. So for part A, okay, let me go back. if you don't remember how to enter the data, or you don't have it entered, you can go back to my last lesson. But essentially what we had to do was go to a data and spreadsheet file. We had to enter all of the X and Y values. I gave them labels. And then I pressed menu, number 4, statistics, stack calculations, and I went to linear regression. Click that button, and then it spat out the linear regression line. So let me write that out again. It was y is equal to 2.16x plus 1.42. There it is. Now, today we also want to know, because we're looking at regression, we want to know the r value. Not r squared, but if you look down at the bottom, r. So I'm going to put comma. R is equal to 0. Round to 3 decimal place, or 3 significant figures. R is equal to 0.993. There it is. Okay. So what does that tell you? What can you interpret? If the R value is so high, this is a strong correlation, a strong positive correlation. So we know then the correlation, as you live further from school, it takes longer. That makes sense. It's a strong correlation. Okay, that's it. That's the lesson. That's easy. I just want to show you part B. This is something we talked about a few sections ago. Calculate the regression line and correlation coefficient of x on y. This is the opposite. I want you to give me a regression line for x in terms of y, so that you can go backwards. If you remember, what I told you a few lessons ago is this regression line can only be used to find y if you know the x. So you sub in an x value, it spits out a y. Doesn't go the other way around. You can't sub a y value into this and get x. Doesn't work because the data is not symmetrical. What you have to do is use the calculator to find a regression line for x on y. So let's find a regression line for x. I'm going to press menu, data statistics, stack calculations, and I'm going to go linear regression. Oh, I just made a mistake. Menu, statistics, stack calculations, linear regression. Press enter. Now, this time I'm going to reverse it. So my x coordinate is my x values are actually time, and my y list is actually distance. Right? It's reversed. And now I'm going to save that. Sure, whatever. I press enter, and there it gives me a new column. And I think you can actually scroll up and see. Yeah, if you scroll up all the way, you can even see what you're using. So time is your x coordinate, y is your distance is your y coordinate. Anyways, if we scroll down, we see mx plus b, and we have these new values. So we have, I'll write them, put this here. So I have 0.457x minus 0.508. Oh, shoot, but remember the variables are reversed, so this is y now, my bad. So x as a function of y. And the correlation coefficient is, 0.993. R is equal to 0.993. So that is the regression line for x on y. So if you have a y value, you can sub it in and predict x. If you want to see why this happens, if I go to my graph and now that's all my data, that's my first regression line. Let me graph the other regression line. And there you can see it down there. Like, it's a different regression line. So of course, if you're making predictions, they're going to be different. That might be confusing. Regardless, this is a very important fact. It's being emphasized in the new IB curriculum. Be careful. This can give you a y only, and then you need this if you want to get an x. Some students get confused. How do I know which is which? Well, this is how I would say. Like, if you get a question like this, calculate the equation of the regression line of y, like on x or x on y. If you're getting confused, just block out the second part. So the first question then is calculate the equation of the regression line of y. Okay, y equals. Calculate the equation of the regression line of x. Okay, x equals. That makes sense, right? That's what I just wrote. Y equals x equals. So that helps you if you get confused. Finally, note that even though the regression lines are the same, the data still fits the same. So the R values are the same. That's no accident. That'll always be the case. Okay, so let's make some predictions now. Oh, sorry, I was just going to make a note here. So the regression lines are different. Unless it's a perfect regression. So that's the whole problem. Unless it is a perfect correlation. Because it's not perfect, you have to use these two values, these two equations. So now for part C, find the predicted time to travel to school if the distance away is 3. So for this, I'm going to sub in x equals 3. So I have to use that first equation. So y is equal to 2.16 times 3 plus 1.42. You could do this. So you could do this with your regular calculator. This might be a good opportunity to just, okay, I have my regular calculator right here, 2.16 times 3 plus 1.42. I'm so quick with this thing because I used it all my life. And that gives me 7.9 minutes. It seems to make sense. The last question, D, find the distance from school if the time to travel is 48. So this time I know what y is. I'm going to sub in y equals 48. But I need to use that that second equation. So x is equal to 0.457 times 48 minus 0.508. Now, again, you could use your calculator. This is very reliable because you're so comfortable with it. But let me just show you, if you really wanted to, you could go back to your calculator page. And I could type, this is a little awkward, but I could type stat. Go down to, I don't think I can use the function, can I? Oh, look at this, F3, which remember, that's where the calculator stored my most recent regression line. And now it says sub in the next value. Well, I'm going to sub in 48. And then it gives me the answer, 21.4, which is pretty amazing. Just be careful, right? Because if I had selected F1, that's the regression line from when I did this with the other in the other direction. So if I use this one, it would have given me the wrong answer. So maybe that's not as reliable, right? Like maybe you'd rather do the calculation by hand so that you can see the work being done in front of you. But it does show you how powerful the calculator is. So that's it. That ends off our statistics chapter. The big application of this is at some point in an IB test, you will have to find a linear regression and the corresponding R value. They both happen via the same function, and then you might have to interpret or do some analysis or modeling using that information. Here's your homework for tonight. Again, GDC is required, and we'll see you next time.